In this lesson, we're going to focus on solving literal equations. Before we can solve a literal equation, we need to understand what one is. A literal equation is an equation with two or more variables. To solve a literal equation for one variable, you are going to use inverse operations. And as we remember, inverse operations are addition and subtraction, as well as multiplication and division. Before we get into example 1, I want you to recall what you would need to do to solve this equation for x. We would subtract 7 on both sides, and that would give us x equals negative 19. Now notice, we were solving for x, so we moved what was being added or subtracted. That is actually going to be our same process when solving for the variable a. The only difference is instead of having a constant of 7, we're actually going to have a variable of b, and instead of the constant negative 12, we're also going to have the variable c. But when I'm isolating, I'm still going to look for anything that's being added or subtracted. B is being added, so I'm going to apply the inverse to both sides of the equation. And I'm going to simplify what I have. So I end up with a equals, my b terms cancel. Now up here, negative 12 minus 7 could be simplified to negative 19. However, in example 1, c minus b is not something that can be simplified. So we're simply going to rewrite it into our final answer. So we solved this literal equation, that's an equation with more than one variable, for the variable a by applying inverse operations. So it may look different, however, it's the same solving process you've been using. Go ahead and try solving y minus 9 equals 34. So after solving, we end up with y equals 43. We applied the inverse operation of adding 9 to both sides in order to isolate the variable y. Try your best to solve example 2. Notice that this will be the exact same process as we had in the above equation where we solved for y. The only difference is when solving for the variable d, we are going to apply the inverse operation to e by adding it to both sides. We cannot simplify f plus e, so we're going to go ahead and just write it into the equation for our final answer of d equals f plus e. Again, it's the exact same process you already know pretty well at this point. It's just a matter of leaving it in all of the terms of variables because we can't simplify any further. Go ahead and solve this negative 6x equals negative 30. When solving, we end up with x equals 5. We applied the inverse operation of division because 6 was multiplying x. We divided both sides by a negative 6, and that's how we got our positive 5. The process is going to be exactly the same for example 3. Try your best and check your answer. So in this case, they've asked us to solve for the variable r. So I've got to ask myself, what is happening to r? Well, I've got a 2 and a pi touching it. Two terms touching, no symbol in between, means multiplication. The inverse of multiplication is division. So I'm going to divide by 2, and I'm going to divide by pi. What I do to one side of the equation, I need to do to the other side. So I end up with c divided by 2 pi equals r as my final answer. Notice again on literal equations, I'm going to end up with more than one variable in my answer, but my process of solving is exactly the same as if I was just solving an equation. Go ahead and try this y divided by negative 4 equals 8 equation. In solving this equation, we end up with y equals negative 32. We multiplied both sides by negative 4 because that was the inverse operation of dividing by negative 4. Go ahead and try example 4. Check your answer. So they want us to solve for m. So we're going to go ahead and get rid of variable v, which is dividing, since it's on the denominator, by multiplying. when we simplify our work, one thing we should know is when we're multiplying variables, they always need to be put in alphabetical order. So D comes before V, so I'm going to get dV on my left side equals M. You know you finished solving when you've isolated the variable that they've asked you to solve for. So in this case, M equals dV. We're going to go ahead and have a similar problem so we can compare our work. 7 equals 5 plus 2x. So in this problem, if I was told to solve for x, what would be my first step? I would subtract 5 from both sides. Now we can simplify 7 minus 5 into 2 equals 2x. What do you think is the first step for example 5? Hopefully you saw that if we're solving for variable w, we are going to move the 2L to the other side. Because it's being added, we are going to subtract it, which is the inverse. What we do to one side, we also need to do to the other side. So we're going to simplify what we have. We can't simplify p minus 2L any further, so we're going to go ahead and just write it as we see it. P minus 2L equals, and then we have 2W. What do you think is the next step in solving our 2 equals 2x equation? The next step in this equation over here is to divide both sides by 2, so we end up with 1 equals x. We know we were done solving because we isolated the x term. What do you think is our next step in solving for w? Hopefully you saw that the 2 coefficient is multiplying, so our inverse would be to divide. This is also where things get a little different. We're going to go ahead and put 2 underneath as the denominator for the numerator p minus 2L. Simplifying our work, we get a final answer of p minus 2L divided by 2 equals w. In order to help us with example 6, we're going to have an equation with one variable to compare. So if I had 10 equals 1/2 x, what would be my first step in solving for x? My first step in solving for x would be to multiply by the reciprocal, because that will cancel my 2's and my 1's. Whatever I do to one side, I also have to do to the other side. Remember, it can make it easier to multiply by fractions if I turn both numbers into fractions. I can always put a number over 1 because it doesn't change the value. 10 divided by 1 is still 10. But looking at it as a fraction will help me to know what to multiply. 2 times 10 is 20. 1 times 1 is 1 equals x. And our final step, 20 divided by 1 is 20, which is our solution for x. We know we're done solving when we have the variable isolated. So let's compare that to example 6. What do we think is our first step? We're going to multiply by the reciprocal of 2 over 1. If we do it to one side, we also have to do it to the other side. So that's going to give us over here, I'm going to put a over 1, so that way I have both fractions to work with. 2 times a is 2a. 1 times 1 is 1 equals my 1/2 canceled, and I'm left with bh. 2a divided by 1 can be simplified into 2a equals b times h. My next step to simplify for the variable b, make sure you know what variable you're solving for, is to get rid of h. H is touching b, which means it's multiplying, so we're going to divide both sides by h. I can't simplify 2a divided by h, so I'm going to rewrite it, and that equals my variable b. I knew I was done solving when my variable they asked me to solve for is completely isolated. So in this final answer, b equals 2a divided by h. Go ahead and try your best with example 7. Don't forget to check your work. So if we're taking a look at example 7, line down the equal sign, and we're going to circle the variable we're solving for. So in this situation, I have to remember that I have some things multiplying, but I also have a term that's being added. And in reverse order of operations, remember that SAD MEPS, I'm going to focus on what's being subtracted or added first. So I'm going to go ahead and subtract pi r squared from both sides of my equation and simplify what I have. I end up with s minus pi r squared on my left side equals pi r l on my right side. What do you think is the next step? Again, we want to make sure we know what variable we're solving for, which in this case is L. What is happening to L? Pi and R are multiplying. We know they're multiplying because they're touching each other with no symbol. The inverse will be division. So we end up writing our answer as s minus pi r squared divided by pi r equals the variable L. What do you think is our first step on example 8? One thing that we have to remember is when I have a fraction where everything in the numerator is all together, I actually need to take care of what's being divided first. So I'm going to multiply both sides by m, since that's the inverse operation. I get ms equals, my m's cancel, and I get w minus 10e. I remind myself what variable they've asked me to solve for. In this case is w. What is happening to the w? I'm subtracting 10e. So my last step is to add 10e to both sides of the equation. My final answer is ms plus 10e equals w. And there is my final answer. That can't be simplified any further. So the one thing to know with literal equations, if you're wondering why are we doing this, is if I was to know what both m, s, and e are, I could plug those values into this equation and it would tell me the value of w. Literal equations can be helpful with word problems because you can manipulate the equation so that way you can plug in for the variables that you know in order to solve for the variables that you don't know. You've completed the notes for this lesson, so go ahead and work on the practice problems to check for your understanding. Thank you for being awesome.